Example 1c. Solve the quadratic equation 2x squared minus 1 equals 23. Now notice we have to do some algebra to rewrite this equation into a form quantity squared equals k. So let's begin by solving for x squared. To do that, we need to add 1 to both sides first, so let's add 1 to both sides. And that'll give us 2x squared equals 24. And now let's continue. We're solving to get a quantity squared on the left, so let's divide both sides by 2. And that gives us x squared equals 12. Notice we are now in the form where we can apply the square root property. Quantity squared equals some value k. How do we do that? We take the positive and the negative square root on the right side. Now, I'm going to use the shorthand notation and say that when you take the square root of x squared, this is equal to plus or minus the square root of 12. Can we simplify this farther? Yes. We can take the square root of 12, and let me look at that. The square root of 12, although not a perfect square, is equal to 4 times 3, and 4 is 2 times 2 times 3. That shows us that the square root of 4 is 2, or in other words, there's 2 factors of 2, so we can pull out a factor of 2, and the square root of 12 simplifies to 2 times the square root of 3, which we write as x equals plus or minus 2 times the square root of 3. Our solution set then consists of the two numbers, negative 2 times the square root of 3 and positive 2 times the square root of 3, both of which, when we substitute back in for x into our original equation, should give us a true statement. And again, I'll leave that check for you. Example 1d. Solve the quadratic equation negative 5y squared plus 4 equals negative 12. Again, observe we need to do some algebraic manipulation in order to get our equation in the form quantity squared equals some positive number k. So let's do some reverse operations and isolate y squared. We begin by subtracting 4 from both sides of our equation. On the left, that leaves us with negative 5y squared equals negative 16 on the right. Divide both sides by negative 5, and that gives us that y squared is equal to negative divided by negative is positive 16 over 5. So we now have a quantity squared equals some positive value. We can apply the square root property. That tells us that y is equal to either the positive or negative square root of 16 over 5. And again, I'm going to use the shorthand notation to denote those two answers. Y is plus or minus the square root of 16 over 5. Now we need to simplify this result. When I have quotients that cannot be simplified under a square root, I like to take the square root on top and the square root on bottom separately. So that's what I'm going to do. I'm going to take the square root of 16 over the square root of 5 and simplify it this way. Now the square root of 16 is simply 4. And the square root of 5, well, that will have to stay as the square root of 5, at least for now. So let me rewrite that as 4. The square root of 16 is 4 over the square root of 5. We have a rule that says that we don't like to leave square roots in the denominator of fractions. And how do we get rid of that square root? Well, we rationalize the denominator. In this case, I'm going to have to multiply both the denominator and the numerator by square root of 5 in order to complete that rationalization. So what's that going to leave me with? That's going to leave me with that y equals plus or minus 4 times the square root of 5 all over, and square root 5 times square root 5 is simply 5. This does not simplify any farther, so it tells me that my final solution set to this quadratic equation is simply the two numbers, -4 times the square root of 5 over 5, and +4 times the square root of 5 over 5. I'll leave it for you to do the check.